Linear programming. What that means is we're going to be dealing with lines regarding real stuff. So linear programming. So it says graph these lines, use 2 different colors and a straight edge. So it's important that you're accurate, because when we're programming, if you're computer programming, if you mess up with one key, then it throws off the entire outcome of your program. Yes? So it's very important when we start talking about linear programming graphs that you're very accurate, which is why I want you to have 2 colors for this first page and a straight edge. So if I want to graph this first equation, is it in the right form? No, not at all. Can I put it in the right form? Yes. So go ahead and switch yours for me. I'm going to take my 2x plus 4y equals 0, and I want it in what form? Y equals. Okay, so I'm going to kind of talk it through. You're working it on your paper. I'm going to go ahead and move my 2x to the other side. So what's remaining is 4y is equal to a negative 2x plus 0, and I'm just going to leave that off. And then I'm going to divide by 4. So y is equal to negative 1/2 x, because 2 divided by 4 is 1/2. So this equation is actually y is equal to negative 1/2 x. So what's my y-intercept? 0. I don't see it, do I? I don't have a plus or minus anything on the end. So it's going to be a 0. So take one of your colors. Well, first take your pencil. Take your pencil, and I need you to draw an x and a y axis. So you're going to draw an x and a y axis on this graph. You're just going to find the middle and find the middle. All right, once you have your x and y axis, pick up your color, and let's graph this first line. The first line says y equals negative 1/2 x. So where do I start? At 0, 0. So I'm going to put my first dot at 0, 0. And then my slope tells me what? Go down 1 and right 2. So down 1 over 2, down 1 over 2. And I'm going to go ahead and go all the way through the graph. And then I'm going to go backwards, please. I'm going to go up 1 and over 2. It's the only time you go left. And then I'm going to pick up my straight edge. And I need to check what kind of line do I have, solid or broken? Solid, because it's an equal sign. So I'm going to go ahead and pick up my straight edge and draw my line straight through those points. All right, once you have your line drawn, since it's an equal sign, do I need to do any shading? No. And so it's done. Go back. I've got another equation I need to handle. So is that second equation in the right form? No, it needs to be in y equals. This one's pretty easy to move, right? So all I need to do is subtract an x from both sides. So this is y is equal to negative x. Would you agree? Yes. What is your y-intercept? 0. So I start this new line at 0 again. And now my slope is down 1 over 1, because it's a negative 1. If I look in front of the x, I see a negative sign only. So that means it's a negative 1. So down 1 over 1. And I'm going to go all the way through the graph, please. All the way through the graph and backwards, then your line. So once I get this graphed, I know that it is an equation, which means it has an equal sign. So that's why I have a solid line. There is no shading because it's an equal sign, and I can tell that there's a point of intersection. How many intersection points does it have? Just one. And where does that happen? That is the solution at 0, 0. The solution of this equation is at 0, 0. Now this is really easy, right? This was one of the first things we did. So go ahead and take a minute, glue this in. Fold it in half, glue it in. I'm bringing you another paper. All right, on the next page, you notice how many different lines that I've given you. How many different lines on this next page have I given you? 4. So what I want you to do before we begin, go ahead and draw your XY axis, but listen, this XY axis, I just need one quadrant. So I just need one quadrant on this graph. So if I just need one quadrant on this graph, that means I don't have to draw in the middle. I just need a quadrant 1. All right, on the second page, you've drawn your XY axis where you can have just quadrant 1 because that's all we're going to need. If you look at your equations, these aren't equations anymore, are they? They're inequalities. Be very careful. Broken or solid lines and shading. So here's what I want you to do right now. I want you to take and graph this first inequality, just the first one. So the first thing you need to do is rearrange it and then graph it and hold. So did you rearrange it to where you got y is less than or equal to negative 1/2 x plus 10? The only time that symbol will flip, you notice the symbol, the less than or equal to, it stayed the same, yes? When's the only time that it flips? If you divide by or multiply by a negative. And I did not do either of those things when I've solved this. So did you get this graphed? Okay, so where do I start? At positive 10. So I'm going to come here to my one quadrant graph, and I'm going up to positive 10. That's my starting point. And then my slope tells me that I go down 1 and over 2 because it's a negative 1/2. And I need to go all the way through, please. And then grab your straight edge and draw your line. When I draw this line, I have to make sure I'm checking the original. The original is less than or equal to, which means I use a solid line. When I'm dealing with inequalities, these lines become what are known as constraints. If you are going to constrain something, what does that mean? You tie it up. You restrict it. Okay? So when I'm given a system like this with 4 different things going on, there's going to be restriction on it. The constraints. The constraints are going to be at the line, and it's going to involve the shading. I'm looking to get a feasible region. So let's talk about that word. I know I have the word constraint. Constraint basically means to restrict. So I'm going to have some constraints on whatever the problem is, whether it's the amount of snow blowers I can produce or the number of cotton seeds I will be able to procure. There will be constraints on those things based on weather, based on employees, based on all sorts of different things. Those are your constraints. Once you have your constraints, your restrictions, then you're going to be looking for a feasible region. So I've got the first inequality graphed, and I know that's going to be some form of constraint. So let's talk about this word feasible. Have you heard that before?
Yes.
Sometimes your parents may say, yeah, that's not feasible. Right? No?
My mama don't use big words.
So what does feasible mean?
I don't know.
Region.
So if I were having a conversation with someone and they said, I've got this gold bar I want to sell you.
Would it be possible?
It's only $10,000. And I'm like, well, that's not feasible right now. It's not possible. If it's not feasible, it's not possible. I don't have 10 grand sitting in my back pocket. If I'm looking for a feasible region, I'm looking for the area that is possible. So your feasible region is just your solution area. The feasible region is the area on your graph that involves the solutions. So can you make 57 snow blowers? I don't know. How much time do I have? 3 weeks. Let me check my feasible region. Okay, based on my constraints. So I've got one equation or inequality graph, but what have I not done yet? Shading. So using the same color that you graphed that line with, where do we need to shade? Above or below? Below. And I'm going to switch to highlighter. Make sure you're shading very lightly. Very, very lightly, not dark. All right. So I know right now my feasible region is anything here below 10 on the y-axis and below whatever that far point is, 15, I think. Or more, 18. Maybe 20, whatever. But it's going to be below 10 and below that far x point. Let's keep going because I have some more constraints. Looking at the next inequality, is it in the right order? No, it's not. So let's reorder it. So if I reorder this second inequality, then can you do that without the work?
Yeah.
Y is
-x
less than or equal to negative x plus 12. All I did was move the x to the right side by subtraction. So now I need to graph this next line. So go ahead and graph this next line using a different color. Where do I start? Positive 12. Well, this is positive 10. So here's positive 12. And then my slope says negative 1. So that means I go down 1 over. I can already see that my new constraint, my new inequality is cutting into my other one, yes? So I'm kind of reducing the feasible region. That's what you should expect to happen. Is this going to be a broken or a solid line? Solid line. Shading? Where? Shading below. Good. Go ahead and take care of those things. So I've graphed my new line. And now I know I need to go ahead and shade. Decided I'm going to shade below. Again, shade very lightly below that second color. And now my feasible region has been restricted. I put some constraints on it to where it's just where my two colors are crossing. So far my feasible region has shrunk a little bit. What do you think we're going to do next? Graph the next one. All right, so that next line or that next inequality says x is greater than or equal to 0. So what kind of line is that? A vertical line. Where? At 0 on the y-axis, traveling through 0 on the x-axis. So my next vertical line, my next line will be here on the y-axis. So go ahead and we're going to draw that. Solid or broken? Solid. Good. All right, so now this inequality starts at 0, and I shade which direction? To the right, because it says that it is greater than. So if it's greater than, I'm shading to the right. Do I have to shade all the way? So do I need to start up here and shade all the way? Not necessarily, because what am I looking for? The feasible region. So I'm probably going to not waste my time with that. And I'm going to come down here where my graphs are already starting a two-color change. And I'm going to go ahead and start with my other color here. Now I have one inequality left. That one inequality says what? That y is greater than 0. Okay, so what kind of line will I have? Horizontal where? On the x-axis. A horizontal line on the x-axis. I need a new color. Let's go with purple. So I'm going to have a horizontal line on the x-axis, and my shading will be above. Yes? Let's take care of that, and we'll check back. Now, when I'm dealing with my y, I know that I'm going to be shading above. Again, I'm not going to waste my time coloring the whole dang graph. I'm going to go ahead and deal only with where my two colors are, or my now three colors are crossing. And I can see that my feasible region has been reducing quite dramatically, yes? And once I have that done, then can you identify the feasible region? If I make my line a little bit bigger, let's use this one, then I can say the feasible region for this problem is right here. This right here, where mine is turning black, is your feasible region. Now, depending on what the problem is or what they're asking, I'll be able to determine what solution is going to be a viable one. Now, we're going to go ahead and glue this in just on another new page. And I'm fixing to give you an additional paper.